That means if you translate that for solid density, you end up with a size that must be larger than 5 kilometers. Now, this is just a lower limit. It could be much larger than that. It could be larger than Manhattan Island.
An object from beyond the stars has entered our solar system, and it's unlike anything we've ever seen. In the summer of 2025, a faint point of light appeared in the data of the Atlas Survey telescope in Hawaii. At first, it seemed unremarkable, another small body traced against the stars. But as astronomers began plotting its motion, one fact became clear. This object wasn't bound to the sun. It was coming from interstellar space. They named it 3I Atlas, the third confirmed interstellar visitor after Oumuamua and 2I Borisov. Within weeks, it became clear that this one was different. Much larger, much heavier, and somehow more precise in its movement. The first step was to measure what it truly was. Observations from hundreds of observatories across the globe, from Chile to Japan, revealed subtle changes in its position. The object's acceleration didn't quite match what pure gravity predicted. Usually, when a comet warms as it approaches the sun, gases vent from its surface and produce a measurable push. But 3I Atlas barely moved. Its jets seemed too weak to explain its size, and its path too steady to be random. Calculations showed that its core could weigh over 33 billion tons, several thousand times heavier than expected for an object of its brightness. That meant one of two things. Either its composition was unusually dense, or its activity was unusually controlled. For comparison, Oumuamua, our first interstellar visitor, was at most a few hundred meters long. 2I Borisov, the second, resembled a typical comet, but 3I Atlas measured close to 5 kilometers across. Its sheer mass made it an outlier in every model of interstellar debris. Dr. Avi Loeb and his team at Harvard examined the data. They compared 227 independent observations from May through September 2025. Their analysis confirmed the strange non-gravitational acceleration, barely measurable, yet real. To Loeb, the numbers hinted at something deeper. He proposed that if the object's trajectory was so precise and its mass so great, there might be more at play than simple physics. It was a suggestion that caught attention and controversy. Was 3I Atlas natural, or could it be technological? NASA urged caution. Most evidence still pointed toward a natural comet, but the discussion revealed how little we actually know about interstellar objects. They enter our system without warning, move at extraordinary speed, and leave before we can fully study them. This time, however, things would be different. For the first time, we had a chance to watch one up close. By early October 2025, 3I Atlas was racing through the inner solar system on a path that would bring it close to Mars. Two European spacecraft, Mars Express and the ExoMars Trace Gas Orbiter, were in position to observe it. Neither was designed for this kind of mission. Their instruments were tuned for planetary science, not interstellar comets. Yet they offered humanity's closest vantage point. On October 3rd, as the object made its nearest approach, the cameras aboard ExoMars began taking long exposures. Against the blackness of space, a faint white glow appeared, a soft haze drifting slowly across the frame. That diffuse glow was the coma, the thin envelope of gas and dust evaporating from the nucleus as sunlight struck it. The nucleus itself, perhaps only a few kilometers wide, was invisible, buried deep within that expanding cloud. The CAS's imaging team described the challenge. The object was 10,000 times fainter than anything their camera usually tracked. Each frame required long, delicate exposures to capture even a trace of light. Still, the coma emerged, proof that 3I Atlas was active. As the comet approached the sun, its gases began to sublimate, dragging dust outward and forming the beginnings of a tail. But even then, the tail was barely visible. Some scientists wondered if the material around the nucleus was unusually heavy or magnetized, something that resisted the solar wind more than expected. On the surface of Mars, NASA's Perseverance rover joined the watch. Its navigation camera wasn't meant for astronomy, but one night while scanning the sky above Jezero crater, it recorded something extraordinary. A thin, luminous streak cutting diagonally through the darkness. When engineers examined the frames, they found that the streak matched the predicted motion of 3I Atlas. The image quickly spread across scientific networks and social media. Some called it engineered, others an artifact. When measurements were made, the streak appeared almost 50,000 kilometers long, far beyond the object's actual size. The explanation, scientists concluded, was motion blur, the combined trace of the comet's faint light across a stack of short exposures. Yet even knowing that the sight of it, a silent visitor captured from another planet's surface, was haunting. Back on Earth, researchers waited for more data from Mars orbit. The High-Resolution Imaging Science Experiment, or HIRISE, on board Mars Reconnaissance Orbiter, was set to provide the sharpest view yet. But just as the object reached its closest point, NASA's public data channels went quiet. A government shutdown in early October froze many operations and delayed updates. Suddenly, the world's main source of live telemetry fell silent at the exact moment an interstellar object was passing by another planet. To some, the coincidence felt almost scripted. For planetary scientists, it was simply bad timing. A bureaucratic pause during a moment of genuine discovery. Still, the absence of real-time information fed speculation. Was something being hidden, or was it just circumstance? Meanwhile, the European Space Agency continued to release their observations. The ExoMars orbiter confirmed the presence of a faint, pink-tinged coma around the object, seen as sunlight scattered through vaporized dust. No strong tail, no visible fragmentation, just a slow, consistent outflow. From these readings, scientists determined that 3I Atlas was remarkably stable. Despite being struck by a coronal mass ejection in late September, there was no sign of breakup. Its shell appeared intact, its trajectory unaltered. At roughly 60 kilometers per second, it continued accelerating toward its perihelion, the closest point to the Sun, where it would reach over 150,000 miles per hour. On October 29th, it would pass behind the Sun from Earth's view, hidden in glare. Instruments at Mars and the L1 solar observation point would monitor it as jets of gas erupted from its warming crust. Then, in December, it would make its nearest approach to Earth, still a safe 170 million miles away, but close enough for the James Webb Space Telescope and the Vera Rubin Observatory to analyze its light in exquisite detail. Each observation brought new puzzles. Spectral readings hinted at nickel without iron, an unusual composition that some called provocative. If confirmed, it could suggest material forged in environments unlike our own solar system, or even something manufactured. NASA remained skeptical, preferring natural explanations. But the idea lingered. An interstellar traveler with a density far beyond expectation, a chemical fingerprint that didn't fit the norm, and a path too precise to dismiss. While scientists debated its origin, others looked further ahead. Astrophysicist Suzanne Finner proposed that objects like 3I Atlas might play a key role in the evolution of planetary systems. In her simulations, when an interstellar body plunges into a young star's disk, it acts as a seed, a ready-made core around which gas and dust can rapidly accumulate. Instead of taking millions of years for small particles to merge into planets, a captured interstellar object could jump-start the process, forming gas giants in a fraction of the time. The correlation was striking. Massive stars, which are better at capturing such visitors, often have more giant planets. If true, it means that travelers like 3I Atlas aren't just cosmic wanderers. They're catalysts, spreading the ingredients of worlds across the galaxy. Back in our own system, missions were being planned to follow the object's path. The JUICE spacecraft, originally designed for Jupiter's moons, could potentially adjust its trajectory for a distant intercept. The probability was small, but the idea captivated mission planners. A close sample of an interstellar object, even dust, could answer questions about the chemistry of other stars. For now, the plan was to continue remote observations, measuring isotopes, studying outgassing patterns, and refining models of its orbit. By March 2026, 3I Atlas would pass near Jupiter, about 33 million miles above the cloud tops, before slingshotting out of the solar system forever. After that, it would fade from view, another streak of light vanishing into the black. In its wake, it would leave terabytes of data and a deeper sense of how small we are amid the larger traffic of the galaxy. Somewhere beyond the sun's reach, it will continue its journey, carrying dust, ice, and perhaps secrets of its home star. It may drift for millions of years before entering another system, another young world forming somewhere else, repeating the cycle. For astronomers, 3I Atlas is both a mystery and a promise. A reminder that our solar system is not isolated. It's part of a much greater ocean where fragments of other worlds occasionally cross our path. Whether natural or not, this visitor has already changed our understanding. It has shown that interstellar objects can be large, stable, and ancient, that they can survive the extremes of travel between stars, and that we now have the technology to detect them before they're gone. When the data silence lifted and new images arrived, they told a simple truth. 3I Atlas was still there, moving quietly through the dark, indifferent to our questions, unbothered by speculation. What it represents, however, may last much longer. In studying this single visitor, we may come to understand how many other travelers are out there, unseen, threading between the stars. And one day, when another faint light appears in the telescopes, we'll be ready, wondering once again who or what might be passing through.